What is software? The product that software professionals build and then support over the long term. Software encompasses 3 points. 1. Instructions, that is computer programs that when executed provide desired features, function and performance. 2. Data structures that enables the programs to adequately store and manipulate information. And 3. Documentation that describes the operation and use of the programs. Software products. They are classified into 2: generic products, customized products. Under generic products, they are standalone systems that are marketed and sold to any customer who wishes to buy them. Example: personal computer software such as editing, graphics programs, project management tools, CAD software, software for specific markets such as appointments, systems for dentists. And coming to customized products, software that is commissioned by the specific customer to meet their own needs. Example: embedded control systems, air traffic control software, traffic monitoring system. Why software is important? The economics of all developed nations are dependent on software. More and more systems are software controlled. Example: transportation, medical, telecommunication, military, industrial, entertainment. Software engineering is concerned with theories, methods, and tools for professional software development. Expenditure on software represents a significant fraction of GNP in all developed countries. Software costs. Software costs often dominate the computer system costs. The costs of software on a personal computer are often greater than the hardware costs. Software costs more to maintain than it does to develop. For systems with a long life, maintenance costs may be several times development costs. Software engineering is concerned with cost-effective software development. Features of software. Its characteristics that make it different from other things human being built. Features of such logical systems are as follows. Software is developed or engineered. It is not manufactured in the classical sense, which has a quality problem. Software does not wear out, but it deteriorates due to changes. Hardware has a bathtub curve of failure rate. High failure rate in the beginning, then drop to steady state, then cumulative efforts of dust, vibration, abuse occurs. Although the industry is moving towards a component-based construction, example, standard screws and off-the-shelf integrated circuits, most software continues to be custom built. Modern reusable components encapsulate data and processing into software parts to be reused by different programs. Example, graphical user interface, windows, pull-down menus in libraries, etc. Failure curve for hardware. You can notice in this diagram, the failure rate is very high in the initial stage, that is, infant mortality is very high, and later on, whenever we rectify the failures and the hardware starts functioning well, and as time passes on, it deteriorates, the hardware components gets deteriorate, and again the failure rate increases, that is, the wear out is very high, and ultimately we are getting a bathtub curve. Software wear out versus deterioration. In the initial stages of the software, there will be very high failure rate, and by doing corrections, the failure rate can be brought down, and we can maintain an idealized curve, that is a constant curve. But whenever changes are being introduced into the software, there will be increase in failure rate due to the side effects. They are to be brought down. Again, by introducing the changes, the failure rate get increases, which gives the side effect, which are to be brought down, and so on and so on. The actual failure curve gradually increases. Software applications. System software such as compilers, editors, file management utilities. Application software, standalone programs for specific needs. Engineering or scientific software, characterized by number crunching algorithms such as automotive stress analysis, molecular biology, orbital dynamics, etc. Embedded software resides within the product or the system. Product line software focuses on limited marketplace to address mass consumer market. Web applications, network-centric software. As Web 2.0 emerges, more sophisticated computing environments is supported integrated with remote database and business applications. Artificial intelligence. Software uses non-numerical algorithms to solve complex problems. Robotics, expert systems, pattern recognition, game playing, etc. Software, new categories. Open world computing, pervasive, ubiquitous, distributed computing due to wireless networking. How to allow mobile devices, personal computer enterprise systems to communicate across vast network. Net sourcing. The web as a computing engine. How to architect simple and sophisticated applications to target end users worldwide. Open source. Free source code open to computing community. Also, data mining, grid computing, cognitive machines, software for nanotechnologies. Software engineering definition. Software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. The IEEE definition. Software engineering is the first point. The application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is, the application of engineering to software. The second definition, the study of approaches as specified in the previous definition.